In this video, I'm going to be introducing to you the indefinite integral. And in really the next while, like the next bunch of videos that are going to come out are going to be focusing on indefinite integrals, and then we'll jump into definite integrals. And it'll be basically a review of this, but just with some more steps. So if you recall from my last video, I discussed what is the difference between those two. If you're unfamiliar with that, just to go to the last video and just sort of skip to near the end where I just highlight that. But basically, an indefinite integral, really in a nutshell, is just an integral without any bounds to it. There's no a or b. There's no domain. We're just looking for like a general like formula, I guess you can say. So the first rule of this like integration I want to introduce you to is going to look like this. So let's say we have when a is a real number is a real number. Big surprise. So if we have x to the a, integrating that with respect to x, that's what the dx stands for, we get a plus 1 under a denominator over 1, multiplying xa plus 1 plus c. This is a rule. This is like the very first basic rule of integration. Sort of like you can think of what we're going to be doing in really in this stuff is similar to what when we did with derivatives, right? We had the power rule, these rules, all that. So this is like a rule, or even I guess you could call this a property as well. So basically, what does this mean? So any number, it could be 3, right? Whatever, 3, 4, 5, doesn't matter, whatever number. You're gonna put it, you're gonna add 1 to it, and then put it in the denominator of some fraction with 1, multiplying x a plus 1. So hopefully you notice that it's sort of opposite to the power rule. So I'll write this here, opposite to power rule, kind of, right? I'll show that in just a second. And the c here, this is just a variable or like a letter you use to describe a constant. So if you think about it like this, if we have some function f of x, let's say f of x, let's just say x squared plus 2, right? Now, if we differentiate this, f prime of x, let's give us 2x plus the 0, right? Because this 2 is gone, it's nothing. Now, if we wanted to get f of x back, you could actually integrate the derivative, because the integration is the opposite of differentiation. Integration is like going up in an elevator, and differentiation is like going down in an elevator. The exponent keeps on decreasing for differentiation, but for integration, the exponent increases. So if we integrated f prime of x right here, right, that would be 2x, I should write dx here, 2x dx, integrating this, all right. And well, I haven't really introduced the rules to you just yet, but I'll just do this quickly. X squared plus c. We would write that because while we know it's 2 here, let's say we weren't given this, and then we were just given f prime of x equals to 2x. So we would write c, because the derivative of a constant is 0, but then going backwards from 0 to some constant, you can't really do that. So you have to represent it by a variable c. So hopefully that made sense. So let me just erase this. And I was saying it's opposite to the power rule, so let me just sort of show it to you. If we take the derivative of this guy, we say a plus 1 over 1 x a plus 1. If we differentiate this, right, we know that in the power rule, it's you swing over the exponent, right? So this would have been a plus 1 over, let me keep the colors consistent, a plus 1, then we over x, and then a plus 1, but in the power rule, if you recall, the power rule is ax a minus 1. That's what you're doing, right? That is the power rule. That is what you use to differentiate. So here, we're going to subtract by 1. Oops. Do I want to keep it in the pink? No, I don't. Minus 1. So then eventually a plus 1 over a plus 1, that cancels, x 1 minus 1 xa, which is the same as this. So really, integration and differentiation are opposite. So just, I guess a good idea is like integration is like going up, differentiation is like going down in an elevator. That's the sort of analogy I like to sort of keep in mind when thinking about these things. So they're intertwined. So integration, just the opposite. That's all it is, really. So this is the rule I've introduced to you, or property, I guess, of if you're integrating any real number. Oh, I forgot to mention, very important. This only works when a does not equal -1. Sorry about that, I didn't say that originally. This is extremely important. This only works when a does not equal -1. So if you have 1 over x, it would, because a is a -1, like here, right? And you're trying to integrate this, that is a whole different property. Just for that, I'll show that in the next video, but just keep that in mind. A cannot equal -1 for this property to occur. So let's look at some examples that I've prepared. We'll start off with number 1, and we'll do these in blue. So we have x cubed being integrated with respect to x, and we want to find the, we want to solve this. So the way we do this is we're going to apply this property we just learned. So the property, again, I'll write it on the side, is a plus 1 over 1x a plus 1. So our a here in this case is looking like this 3, right? Because that's the exponent. So let's start off with that. Let's start off with the coefficient. A plus 1, so a is 3. So 3 plus 1 is 4. So we get 1/4. And then we write our x. And then a plus 1, and a is 3. So 3 plus 1, 4. But we're not done yet. Remember, we have to put our c, our constant thing, because we don't know what the we can't really tell what 0 is going backwards, right? You need more information to do that. I'll be showing how to do that in some later, like some video in the future. It's not super complicated. And if you're always unsure, you can always do a gut check. If you differentiate this, right? If you differentiate this, power rule, swing over the 4. 4 over 4 is just 1. 4 minus 1, that's 3. Constant is just a constant, so that's 0, and you get x cubed, which is the same as this guy here. Let's try this. X to the 6. So basically, again, we're just applying the rule. 6 plus 1, 7, like this, plus c. Pretty straightforward, right? We're just using, again, the property we learned. All right, this here, question 3. Integrating 3x. So a here is, hopefully you can see this, but hopefully you understand what I mean by that, but it's just 1 there, right? When there's no like specific exponent written, you just, there's a 1 there. So again, we're going to apply that same property we just learned, right? So our a is 1 here, so 1 plus 1 is 2, right? We put our 2 here and our 1. We would put our 1 here. I'll put the 1 here. Multiplied by this 3, because there's a 3 here, there's a coefficient here. Then x, 1 plus 1 is 2 plus c. Simplifying this, you get 3 over 2x squared plus c. Right? So that 3 obviously is coming from the fact that this is the existing coefficient already. So we would just put that at the end, and that would be 3 over 2x squared plus c. All right. Let's do these ones now. Question 4. Pause the video and actually try this one for yourself. All right, so again, we're just applying the same property we learned. All of these are just applying the same property. Our a value here is 3. So underneath here, it's going to be 3 plus 1 over 1 multiplied by this 2x, 3 plus 1 plus c. Simplifying this, you get 2 over 4, right? 3 plus 1 is 4, x, 4 plus c. And then 2 over 4 can be simplified to half x, 4 plus c. Again, always make sure to write the C. If you don't, you will lose marks for that. Your teacher will not like that because that's incorrect. Because again, you don't know what the value is of that constant. So hopefully that made sense. Now, this is an interesting one. It may look tricky or may not to you, but this one's actually pretty straightforward. So what you have here actually is a 1. You're integrating a value constant 1. Now, the way you can approach this is you can write 1x0 dx, integrating that. x0, because anything to the 0 is just 1. And then you can apply that rule we just learned. So 0 plus 1 over 1 multiplied by 1, x 0 plus 1 plus c. 0 plus 1 is just 1, 1, x 1 plus c, or in other words, x plus c. That's it, actually. I just took a longer step. For some people, I'm sure you saw this, like, oh, it's a 1, so you can just get to x immediately. But that's just how you would do it. So 0 plus 1, all that stuff. All right, let me write a little smaller here. All right, this thing now. 1 over x squared, and we want to integrate this. Pause the video and see if you can try this. All right, so my strategy for reciprocal sort of functions that we're integrating generally is just write it in like this form where your exponent is negative. Just makes your life a little easier, especially when you're learning this in the very beginning. So we're going to apply the same rule we're doing, -2 plus 1 over 1 x -2 plus 1 plus c, because -2 is our a value here. -2 plus 1 is -1, x -2 plus 1 is -1 plus c. In other words, this is -1 over x plus c. All right, number 7, bit of a trickier one. So just like in that last example, I had sort of expressed the exponent as a negative. I'm going to do the same thing here. So this is x -3 over 2, integrating that. And if you're wondering where the 3 over 2 came from, this is x to the half, and this guy is x1, or you can say that's x2 over 2, same thing. So when you're adding 2 over 2 to the half, when you're expressing this x and this x as 1, you're adding the exponents, right? Your exponent laws, remember those? You get 3 over 2, and that 3 over 2 was in the denominator, so I would put a negative, as I've done here, to express it like that. Now we're gonna just apply the same rule again. So a plus 1 in the denominator, so -3 over 2 plus 1 over 1 multiplied by x -3 plus 2, -3 over 2 plus 1 plus c, -3 over 2 plus 2 over 2. I'm just describing this one in a different way. -3 over 2 plus 2 over 2 plus c. So you get -3 plus 2, -1 over 2, 1x, -3 plus 2, -1/2 plus c. Now, if you remember, some algebra from grade 9, you realize that if your denominator is a fraction, this guy can just go up top, right? So that gives you -2x, -1/2 plus c, or in the most simplest form, -2x plus c. So, bit of a long one, but hopefully I wasn't going too fast, or I guess too slow either. I'll just hold the screen here for a second. You can pause the video and see the steps I took. All right, moving on to this one. Again, pause the video and see if you can actually try this one. This is the last one that I'll be going through, and then I have a set of questions that I would like you to try, and I'll take that in the next videos. But pause the video and see if you can try this. All right, so First things first, let's just describe this, in that exponent form I like to, without the radicals and everything. So this would be x2 over 3. Oh my god, well, that is a terrible integral sign. There we go. So x2 over 3. Now, integrating this, so this would just be 2 over 3 plus 3 over 3, 1, x 2 over 3 plus 3 over 3 plus c, right? So 1, 2 plus 3, 5 over 3, x 2 plus 3, 5 over 3 plus c. And then again, if your denominator is a fraction, the denominator of that fraction can just go up top. So that becomes 3 over 5, x 5 over 3 plus c. That is it for that one. So it's similar to question 7 in that sense. And you'll notice a certain pattern. If you actually try integrating this, right? If my memory serves me correct, you'll get this. And you may be wondering, where the hell did that come from? Because if you apply the rule, half plus 2 over 2, 1x half. Yikes. Oh, that was a terrible x. Half plus 2 over 2 plus c. If I'm doing this correct, that's 3 over 2, 1x, 3 over 2 plus c. So then that becomes 2 over 3x, 3 over 2 plus c. Because this 2 here can just go up. So you'll notice a pattern where your exponent will be like how it normally is, adding, and then your coefficient will be reversed. That is if you have nothing really multiplying in this one, by this x, if it's just 1. Just a little neat thing to notice. Hopefully that wasn't too confusing. So part of the series I thought might be a good idea would be to not only show to you how to do these, but also let you try these on your own. So I'll be ending the video here, but in the next video, I'll be just quickly taking these up and then moving on to the next concept. So try these questions. They're not too hard. They're relatively the same as to what I just taught. And if you want more practice questions, just let me know in the comments below. I can think of some more, add them. Or you can always find them off the internet. Hopefully this video was helpful. You can let me know if the video was helpful by hitting that like button or hitting the dislike button to tell me I am terrible at this. Either or is fine. Yeah, besides that, have a good day and I'll see you in the next one.